So again, the centrifugal force that will be applied to your samples within a centrifuge that is actually determining how samples will be separated out during your centrifugation, right? The bigger the force is, it'll well separate out the molecules based on their sizes. Actually, it's a size-based separation. Okay, and then the thing is, the centrifugal force is determined by two main factors. Again, one is the speed of centrifugation, how fast your centrifuge is spinning, and the other one is the size of your rotor, because it's the radius size that determines the centrifugal force. Okay, think about your golf swing. Okay, if you are good at golf, you have a beautiful swing that stretches out your arm. That's going to create more force when you hit the ball, because it creates more radius in your swing. Okay, that's the same principle. Okay, so when you describe the centrifugation condition, so you can use those as a factor. Okay, number one, if you want to describe the centrifugal force that you're applying to your samples, okay, that's RCF, that's relative centrifugal force. Okay, RCF equals relative centrifugal force. That uses the unit of G. Okay. And then that RCF is described as 11.2 times radius times RPM, the speed, divided by 1000 square. Okay, so that's a relationship between the RCF, the force applied to the centrifuge, and RPM. Okay, so in other words, 1.12 times 10 to negative 5 times RPM square times radius. That's the relationship between the RCF and RPM. And if we write the equation to RPM, then RPM equals the speed of the rotation in a revolution per minute. That's what RPM is, okay, revolution per minute. And that can be expressed as 1000 times square root of RCF divided by 11.2 times radius. Okay, so you can convert RCF to RPM and RPM back to RCF. That's what this equation does. Okay, so when you describe a centrifugation condition, okay, do you want to describe that as in RPM, how fast you're going to spin, or do you want to describe it as in RCF, how much of the force should be applied to your sample? Okay, so let's say you're writing an SOP or batch record about your centrifugation step in your drug purification. Then, so what is the right description of your centrifugation? That's the question. Okay, so do you want to describe it as a RCF, how fast you want to set up the speed of your centrifuge, or you want to describe it as a RCF, how much force should be applied? Okay, so which one will be more accurate? Okay, so if you have only one centrifuge with a typical rotor design, if that will be the centrifuge that you will have to use continuously, no matter what, if that's the only centrifuge you can use, then it doesn't matter. You can describe it either way. But if you have multiple centrifuges, and those multiple centrifuges have different rotor designs, so the rotors have different sizes, then it's much better to describe in RCF than RPM. Okay, the reason is because the different rotor design, different rotor sizes will present you with different radius sizes, right? So if you look at this equation, so the radius is a big factor. Okay, so when you describe in RPM, okay, that doesn't consider what the radius size is. Okay, so if you describe in RCF, okay, so it considers both. So so RCF will be more accurate description of your centrifugal condition than RPM, because 1 RPM in maybe small rotor, okay, let's say you're spinning at 5000 RPM using this rotor that has maybe 5 centimeter rotor radius. That's different than the 5000 RPM in another centrifuge that have maybe 10 centimeter radius rotor design. Okay, which one will create more RCF? Of course, the rotor with larger, radius will give you much bigger size centrifugal force. So the centrifugal forces that are applied to two different centrifuges are different, although they are spun at the same speed RPM. Does it make sense? So because of that, you want to use RCF in your centrifugation instruction or description. Okay, so this question is about that. Okay. And then when you centrifuge your sample, of course, how long centrifuge is also relevant. So there's a the time factor, right? So when you present the centrifugal force, do you present the centrifugal force about 5 minutes, or do you present that about 10 minutes? Okay, so time is another factor that influences your separation in your centrifugation condition. So of course, the longer the time you apply, you will have a better separation, right? So timing is a factor. So let's say 5-minute centrifugation at that same RCF versus 10 minutes, the effect is totally different. It may be a much bigger effect here, right? So you need to consider that. And not only that, the size of the rotor also matters. Okay, so the rotor size, the bigger the radius is, of course, it will generate more RCF. So there are three different factors you need to consider. Okay, so of course, one is the RPM, the speed of centrifugation. Number 2 is the size of your rotor, and then number 3 is the duration of the centrifugation. Okay, if you cannot create the centrifugation condition that's written in your SOP, for example, because of the fact that maybe your centrifuge is not reaching the speed that's required, or your centrifuge is smaller in its rotor size, then what you can do is you can maybe extend the time to compensate the difference in the centrifugal force that's created by maybe the rotor size or the speed that you cannot reach. So you can maybe extend the time if the RCF is not same because the speed difference and maybe the rotor size. So there are things that you can control. That's what it means here. Okay, so the exercise 2 is about practicing on your centrifugation. Okay, so you will be given with the E. coli cell overnight culture, and we have a tabletop centrifuge. So you will try to pellet down the cells from the cell suspension of E. coli culture by using a centrifugation. So this is your centrifugation condition. You need to centrifuge at this RCF 2000 G for 5 minutes. Okay, so you will use about 10 milliliter overnight. So you will have to check your centrifuge to create that RCF. Okay, and then 5-minute temperature, 5-minute time duration. And then when you use a centrifuge, another important practice you need to do is what? That is, you need to have an even number of sample. Okay, if you have a single sample, you have to maybe create something that can counterbalance against your sample, because when you use a rotor, the rotor should be counterbalanced. Otherwise, the rotor will be imbalanced and it will be wobbling and it will damage the centrifuge, as you know. So you cannot do that. So if you have a 110 ml sample, you need to create a maybe dummy tube that is filled up with maybe water that will be that will give you equal weight. So the counterbalancing unit should have the equal weight. So you will create a balance on the rotor when it's spinning at high speed. So you will practice that, how you create that counterbalancing of your sample. Okay. So you will be given it a swinging bucket rotor. Okay, and then the tabletop centrifuge, you will try to set up the centrifuging condition and see after the centrifuge you can pellet down the cells. That will be those exercise 2. And then exercise 3 is practice of your aseptic gowning process. So I want you to go to this website, YouTube video, and then play that. It'll explain you how you do the aseptic gowning step by step. It's a very good video. Some of you may have already watched it through your previous class, BIOT 100 or BIOT 102. If that is the case, then maybe you will understand the process. But if you haven't watched this video, this is a really good educational video. They made it well, so you can understand how you can put on your aseptic gowning through the principle of top-down or bottom-up, okay, or inside-out. Okay, so when you put on your gown, of course, you have to put on your scrub first, and then your shoe cover, and then you put on your hairnet and beard cover, and then you will put on your hoodies, and then from top to bottom, full coverall. Of course, that's after your gloves put on, and then goggles and all face mask, and then finally another layer of your booties and shoe cover that completely cover your feet, and then double layers of gloves. So it's not easy as it sounds, because when you grab those gowning materials, you're not supposed to touch outside of those gowning materials, because outside should be all clean and aseptic, sterilized, right? So you're only allowed to grab the inside of those garments, and then the gloves as well. So you need to have some practice on those. And also when you put on your safety goggles and the face mask, it'll also fog up, and you'll feel the awkwardness during the process. So yeah, it's a practice, of course. The more you have on your practice, you will do better in the real job situation. So I want you to take a look at it, and if you want to do that, and we can do the hands-on gowning exercise in our training suite. So that's the third exercise part here. And then I have a homework assignment, so I want you to go visit this website. It talks about the centrifugation process. So there's a e-learning module training, so I want you to go through that and get the training completion certificate, and you're going to upload that in your course shell. That's going to be a 10-point assignment. Okay, so that's it for the lab introduction. Thank you.